Hi guys, so I'm trying this a little bit differently. I'm going to try a new session that to record the answers and also to kind of share the screen with you guys here. See if I can't work through some of these answers and you can let me know if this works out better for you guys. So light bulbs 1, y'all are missing questions 3 and 5. I'm just trying to re-record this from the other one that was upside down. So let's see if this works. Click on either completion or accuracy. If you look at my screen, they are both grayed out, like it's a darker gray. So that means I can actually go into those problems by clicking on this. So I'm going to go ahead and click on that. And it's looking at questions 3 and 5. So I'm going to go ahead and go into question 3. So question 3 says determine whether each light bulb will be bright, dim, or off. And so what's going on with this is that the battery only has one connection. It has something coming out of the positive side, but nothing's coming in through the negative side. So all circuits have to have a full connection to the battery. And by full, I mean it has to connect to the positive and the negative side. So this circuit has a connection to the positive side and goes around and does this loop, but doesn't come back over here. So this one is actually how many complete routes exist in the circuit? None, because the complete route, it would also need to be in here. Let me change the color so I can show you what I'm talking about. It would actually need this connection here in order for it to be a complete circuit, okay? But it doesn't, so this is not a complete circuit. So bulbs A and bulbs B would both be off because it is not a complete circuit. Next question is question 5. Okay, so question 5 is looking at, says determine whether each light bulb will be bright, dim, or off. This circuit is not going to be valid. It does have 2 routes, yes, if you're just looking at the wires. However, for this tells you there's a specific line here. Let me see if I can, right here, this highlight, okay? It says for a short circuit, list the number of routes a short circuit. So this one's actually going to be a short circuit. And why I'm saying that is because short circuits only go through the wires and not through resistors or light bulbs. So for this one, it's actually going to just go, this route is going to go here. So I'm drawing over, sorry, my line is not following quite 100%, but it's going to follow that path. So it's not going to go through these light bulbs. So that's what it means by short circuits. Short circuits do not go through light bulbs or resistors. They take the path of least resistance. So light bulbs A and B are off. Let's see what we can do here. So let's go on to the next one. So the next one is current calculations. So I'm going to go back to my dashboard and go in through current calculations. Again, clicking on completion or accuracy will take me in there. And I'm going to go ahead. So it says analyze the circuit to determine the unknown currents, how many complete routes. So this this is the one that I showed you guys before on the old one. This is basically a mixed circuit. I'm not going to go in the long way. Don't worry about this one too much. I gave you the answer on the previous video. I'm not going to do this one on here. It's just going to take way too long. So I'm going to go into question 4. This one is a simple circuit. It's series. So it's looking for the current. So remember that we have V equals I times R. What, Kimber? Okay. Okay, so your voltage is going to be your total voltage in here from the battery, which is 12. Our current, total current, we still don't know. The R value is the resistance. So for series, it's going to be your total resistance is just your resistors added together. So this is 40 plus 30. So 40 plus 30 is going to be 70. So then I'm going to put in 70 here. So you divide both sides by 70. So 12 divided by 70 was the 0.171. And remember that current for series, they're all equal, right? So total current is equal to current at A and is equal to current at B. So all of your values should be equal, okay? So that's the end of that one. Various, you had problems with 7, 12, and 15, so I'm going to go into those right now. Pause it if you want to take a look at these calculations. Otherwise, I'm going to erase them and move on. Okay, I'm going to go back to the dashboard. Take a look at various. So various, here we go. Okay, the questions I had were 7. So analyze the circuit to determine the unknown voltages. Okay, so how many complete routes in the circuit? Okay, this is series, so it is going to be one route around here. And then it says bulb A and bulb B. Well, bulb A and bulb B, they don't give you, there's no difference in resistances. So for series, the voltages are added together. So each of them is going to receive half of the voltage. We're going to go on to question 12. So this one, analyze the circuit to determine the voltage. Okay, so each of these batteries is 1.5 volts, and we only have one path, right? You have one path, but you have the opportunity to go through 2 different batteries. So on this one, when you get here, you can either go this way or you can go this way. Each of those has a voltage of 1.5. So the 1.5, you can either go, you're only going to get 1.5 volts because you can only go one way or the other. You're not going to add them together because these aren't going through both batteries. You have to choose a path. So it's only 1.5 volts. So that's this one. And then let me go on to question 15. Question 15. So this one is talking about determine the unknown voltages. Each battery has 1.5 volts, but the bulb is not going to get any current. And the reason this is because all of these, the voltage is coming out, or the current is coming out, sorry. But the current has to come up and around, but it needs to come back into this side here, but it can't reach this side without going through here, but current doesn't flow that way. So because it's not a complete circuit and it's not connecting to the negative end, this bulb is not receiving anything, okay? So it's not a complete circuit. There's no way for this current to travel into the negative side of the battery. And I clear all drawings, and we are going on to light bulbs 2. Go into the dashboard. Light bulbs 2. Okay, so this one is a parallel circuit. It's written a little bit weirdly, but it is a parallel circuit. Actually, I don't even need that one. Hold on. We're going into light bulbs 2. I have 2, 9, sorry. So 2 parallel circuit. This one is to determine whether light bulb will be bright or dim or off. Okay, again, light bulbs 2 is really all about path of least resistance, okay? So this one, it's gonna go this way, and it's gonna choose to go this way because it only has to go through one light bulb. If it chooses to go up and around, then it's 2 light bulbs, so that's more resistant. So the first path is going to get all of the voltage or all of the current, so it's going to be bright, and bulb B will be off. Okay, 9 is the next one. Okay, 9, so again, path of least resistance, we're going to go out of the positive end through the first light bulb, and it can either go this way or this way. But either way it goes to that, those are just wires. It will choose to go through the shorter wire because, again, that's going to be least resistant. The longer the wire is, more resistant. But it's going to go this way. It's not going to choose to go through light bulb B because that would be adding in more resistance. It doesn't have a choice but to go through A and C because C is the only way in and A is the only way out. So B it does not go through. Because the light bulbs are sharing that pathway, both are going to be dim, neither one will be bright, and this last one will be off because it's not going to go that way. Okay. I'm going to move on to the next question, which was question 10. And let's go to question 10. Okay, so again, path of least resistance, I'm going to show you the path. So it's going to come out of here. It's going to choose to go through a wire versus going through the light bulb because the wire is less resistant than going through a light bulb. After this, it's going to go through B because it needs to come around and go through the negative side. So this one is going to be off or 0, and this one will be bright because it's receiving all of the current and voltage. So I'm going to back out of this one. Let me go on to the next question. We're almost done, guys. So this one, it is going to be, and you can see I already have all the right answers here. You're going out of the positive end. It's going to go this pathway. It only has one path to go. Biggest thing here, let me see if I can zoom in. So this way you can actually see the wire goes up through the filament here. This one doesn't. So this little like closed wire, so the wires are touching, so the current is not going to go up through this little filament here. So this light bulb is actually off. Okay, it's like having a bad light bulb. And then light bulb B is going to receive everything. I wasn't sure what that little symbol was at the beginning either, so I think I got that one wrong initially. So just so you guys have a clue. I'm going to erase it and move on to question 12. Anything else? Okay, so this one is kind of, it's all about the switch, whether it's open or closed. Again, path of least resistance. It's going to go out of the positive end, and when it goes up here, it either can go through the light bulb or it can go straight through the wire. The wire is least resistant, so it's going to go through the wire. Come back down, it's not going to go back through the light bulb. That's not the way it needs to go to the negative side. So it has to go through bulb B to get through the negative side. So this is going to be bright, as you see here, and A is going to be off. Nothing is going through there. Then the next one, so it's coming out of the positive end. It's going to go up. It can't go through this wire because this is open. So it has to go through this light bulb here, down, and then back through light bulb B. So both of these, they're sharing. Anytime that they share, you're going to see that they're both dim for this pathway. Okay. If it's only one, it'll be bright. If they're two, they're going to be dim. Okay. And that's it for light bulbs 2. We're going to move on to challenge number 3, and then I'll get this posted for you guys. So I'm going to go ahead and erase this. And we're going to move on to dashboard and challenge. This is challenge question 3. I think yeah, it was the only line on the challenge. Okay. So question 3, I'm going to go ahead and go there. Okay, so this one, it says, what is the equivalent resistance for all 3 resistors? Okay, so this one is parallel. You're just solving for a parallel connection, parallel resistance. So remember, it's 1 over 50 plus 1 over 30 plus 1 over 70. And you plug that into the calculator. And so for that, I got 0.0676. And then there's some other numbers. It's 19048. Anyway, just make sure you're not rounding these too soon. If you round it, it's going to throw it off. And I found out that there's only a 1.5% allowance. So if you're off too much, it's going to count your answer wrong. So take 1 over whatever your answer was for this, right? So this was our answer here. And so I didn't round my answer when I'm putting into the calculator. So if you know how to do that on yours, you can do it. So I got my final answer for this was 14.789. And I know it likes 3 decimal places, so I put in 3 decimal places. Okay, so that is what I put in, and it was correct for all 3 resistors. These are the most missed problems. Again, if you have problems you need me to help you with or work with you through them, I can do it either through Zoom or you send me a message. I can explain it in an email, or if I need to, I can do another video. So just let me know as you guys are working through this, and I'll kind of check and see how we're doing this week and post another video on Friday. All right, guys.